Features such as extrudes, revolves, sweeps, and lofts have one thing in common. They all require two-dimensional sketches. There are some features that don't require sketches at all, such as fillets, chamfers, and shells. These features are referred to as applied features because they are applied directly to the model in 3D. In this section of the course, we'll take a look at the most commonly used applied features when creating SolidWorks models. The most common applied feature is the fillet, which is used to break sharp edges in a model. This is the fillet icon. Remember, this is an applied feature, so I don't have to begin a sketch to access it. In fact, if I begin a sketch, the fillet command will not be available. You can also access the fillet command from the drop-down menu under Insert, Features, Fillet, or through the S key shortcut menu. As you can see, there are many properties available when creating fillets. I won't cover all of the options right now. Instead, let's take a look at some key areas. Here at the top, you can see there are two tabs, Manual and Fillet Expert. The Fillet Expert option is designed to simplify the creation of fillets when working with complex geometry by automatically resolving geometry problems. For this lesson, I'll be focusing on creating fillets manually. First, I'll start by defining the type of fillet. Constant size fillet is the default setting, and also the most commonly used. Variable size and face fillets are generally used when dealing with more complex geometry, such as consumer products made up of ergonomic shapes. I'll come back and show you the full round fillet type. Let's continue with the constant size fillet. You can tell that this is an active selection window since it is highlighted. This means that SolidWorks is waiting for an input. If I hover my cursor over the window, a pop-up menu will tell me what type of input to use. I can pick an edge, a face, a feature, a loop, or a combination of each. I have full preview activated. So as soon as I select an edge, you will immediately see what is going to happen. Notice a flag callout appears attached to the entity I just selected. I can edit the radius value from here by clicking the dimension and typing in a new value. Or in the Property Manager, I can specify it by either using the up and down arrows or by typing in a value directly. Notice that the current fillet method is set to symmetric. This means that the radius of the fillet from each end is the same. If you want to create a fillet with two different radii, you can select asymmetric from the drop-down menu and type in a radius for each edge individually, or change the values in the respective flags here in the graphics area. I'll use symmetric in this example. There is also a drop-down menu to select a fillet profile. You can create a fillet with a circular profile, or you can create a fillet with a conic row conic radius, or curvature continuous profile. Rho is a number between 0 and 1 that describes the relative angle of the plane intersecting the cone in a conic. High rows make the conic sharp, while low rows make the conic round. The conic radius lets you numerically specify the radius of the conic curvature. Using the curvature continuous option creates a fillet that is curvature continuous with the adjacent surfaces. I'll set the profile to circular. To accept these settings for the fillet, all I have to do is click the green check, and I'm done. The fillet I just created is listed in the Feature Manager tree, along with the rest of the features used to create this part. There is no arrow icon next to the fillet, like there is next to this extruded boss, because a sketch was not used to create the fillet. If you wish to make changes to the fillet, all you have to do is click on it, and select Edit Feature from the pop-up toolbar. I'll check the multi-radius fillet option, and now I can specify unique values to each fillet. Each flag that appears allows me to control the radius of the edge it points to. The preview will update as soon as I press Enter on the keyboard, or click anywhere else on the screen. Let's edit this fillet once more and take a look at other options. I'll clear the multi-radius fillet option and clear the edges from the selection window. I can pick one edge at a time, right-click, and select Delete, or I can right-click and select Clear Selections to completely clear the window. You don't have to pick individual edges. You can also pick faces. This can sometimes save you time and the trouble of having to pick many edges. When I select the face, the fillet affects every edge that is associated with the face. If you only want to select the outer loop, I can right-click an edge and pick the Select Loop option. This arrow allows me to switch between the two loops associated with this edge. When creating fillets, you don't have to create them all at once. In fact, sometimes you may wish to break your fillets into several steps to get the results you want. This time, I want to round the 4 vertical edges. Notice that with the fillet command active, I can pick through solid geometry to select edges. If it's difficult to see what edges you are selecting, you can always switch to Hidden Lines Visible, which can be found under Display Style. Now, in a different fillet, I'll select this edge, and you will notice that the fillet will propagate around the perimeter. This is because the tangent propagation option is checked. This option causes the fillet to continue as long as there is a tangent edge. There are many more options available with the different types of fillets, but one that can be very helpful is the full round fillet. The full round fillet makes it easy to create rounded faces. For example, you can make a tombstone shape out of this block. First, I'll select the full round fillet type. I'm now prompted to pick 3 faces in these selection windows: the side face, the center face, and the other side face. The result is the perfect blend of all 3 faces. Constant size and full round fillets will help you get going with Solidworks. Chamfers, like fillets, are used regularly to break sharp edges. The difference is that chamfers break sharp edges with angled instead of rounded faces. The chamfer command is also an applied feature, so it's available without the need for a sketch. It can be launched using the chamfer icon or from the Insert drop-down menu. A chamfer can be applied to an edge, a face, or a vertex. We'll take a look at each option, but first, let's take a look at how to specify the dimensions of a chamfer. When I pick an edge, Solidworks will give me a preview of the chamfer and display its current dimensions in a flag, like this one. You can specify dimensions directly in these fields, or in the Property Manager. Currently, I'm using the angle distance option for this chamfer. That's why I have the angle and distance dimensions available. As I change the angle, you can see the preview update, and the same is true as I change the distance. When using an angle other than 45 degrees, you want to be able to tell Solidworks which side is the long side and which side is the short side. You can control this with the flip direction option. These settings are similar when using the distance to distance option, except you have direct control over each distance, rather than using an angle. You can see that you have 2 options to control the distance values with symmetric and asymmetric. If you want to make both the values the same, use symmetric. If you want to have different values for the distances, use asymmetric. You can see that the vertex option is not available. This will only be available when putting a chamfer on a corner. I'll clear this edge by right-clicking and selecting Clear Selections. Now, the vertex option becomes available. When I pick a corner, I'll be able to set 3 separate distances, one for each side of this corner. To finish the chamfer, I simply click the check, and it's done. By selecting a face when adding a chamfer, each edge of that face is affected. By picking this face, for example, both the inner and outer edges are broken. I'll switch to another part by pressing Ctrl-Tab on the keyboard to go through the last 2 options: Offset Face and Face-to-Face. I'll select the Offset Face chamfer type first. You can select faces, edges, features, or loops for this type. I'll select this edge here. Under the chamfer parameters, you can see that I'm currently creating a symmetric chamfer. I'll change the option to asymmetric. Notice that I now have the option to set the offset distance from both adjacent edges. I'll set the first offset distance to 0.35 inches, and the second to 0.4 inches. To help you visualize how Solidworks creates the chamfer when using this option, I have sketched some lines on the model that will serve as theoretical offset lines. 2 of the lines are parallel to the adjacent model edges. These 2 lines are offset by the same distance as I specified in the chamfer property manager. The diagonal line is 0.4 inches from this edge, and the vertical line is 0.35 inches from this edge. Solidworks finds an intersection point between these 2 lines and creates 2 normal lines, which I have represented here with 2 construction lines. You can see from the preview that these construction lines intersect the beginning and end of the chamfer. I'll click OK to accept the change, and the chamfer has been created. Let's move on to the face-to-face chamfer type. I'll reactivate the chamfer tool, and this time I'll select the face-to-face chamfer type. The property manager prompts you to select 2 sets of faces to define the chamfer. I'll select 2 different sets of faces and finish the command. You also have the ability to convert the 2 new chamfer types into fillets. There are 2 ways to do this. First, you can right-click on the chamfer feature in the Feature Manager tree and edit the feature. Under Feature Type, you can now choose between a chamfer or fillet type. You can also convert these chamfer types to fillets by right-clicking the chamfer feature from the Feature Manager and selecting Convert Chamfer to Fillet. Chamfers can also be converted from fillets using either one of these methods. There is another setting that is good to know when using chamfers. It's the Keep Features checkbox, right down here. It is available for all chamfer types except the face-to-face option. If you're working on a model that has a feature very close to an edge, like this boss, you can decide whether the feature will remain after the edge is chamfered, or if it should be removed. This only becomes a problem if the chamfer is large enough to affect the feature. If I don't check Keep Features, the boss is removed. If the box is checked, the feature is extended, so it's not lost. Although chamfers are most commonly used to break edges by removing material, they can also be used to add material. In this part here, for example, if I add a chamfer to smooth out this inner edge, material is instead added to the part to create the chamfer. The shell feature is another useful tool that can be applied directly to a solid model. It will allow you to take solid geometry and make it hollow. This can be a powerful and time-saving technique when designing parts that call for thin walls, such as plastic products. The shell is easy to use. Once you have a solid part like I have here, you activate the shell feature by clicking on this icon, or from the drop-down menu under Insert, Feature, Shell. The settings are rather basic. First, since this will become a hollow part, I have to input the wall thickness I want to end up with. Before taking a look at the remaining options here, let's take a look at what happens if I finish the feature right now. At first glance, it appears nothing has changed. You can see the addition of the shell in the feature manager, but the model appears identical. That is, until we take a look inside. Let's switch to a wireframe display. And now you can see the difference. We have a 1/2-inch thick cylinder with the center completely removed. Now, let's take a look at the other options we have. I'll click on the shell feature and select Edit Feature. If I hold my cursor over this window, you will see a pop-up message that says Faces to Remove. Any faces that are put into this selection box will be removed from the part once you finish editing the feature. I'll click OK, and this is the result. There are two more options we'll look at. This checkbox allows me to specify whether I want the resulting wall thickness to be added to the inside or the outside of the part. When the box is checked, notice the part actually gets bigger. I'll make the shell thicker to make this more obvious. And there you see the result. The last option for the shell feature is the ability to pick faces that require a different thickness than the rest of the part. For example, if you wanted this part to have a wall thickness of 1/2 inch, but you also want the bottom face to have a thickness of 3 inches, just select the bottom face into this window, type in 3 inches, and this is the result. One of the more repetitive tasks, typically performed in mechanical design, is the creation of holes for standard-size bolts and screws. Solidworks provides a time-saving feature called the Hole Wizard, which automates this task. For example, if you need to add a counterbore hole on this face that is properly sized for a 1/4-inch panhead screw, you'll just click on this icon to launch the Hole Wizard. This is the Hole Wizard property manager. It allows you to define the type of hole you're using here on the first tab, and then use the Positions tab to determine the location and the number of holes. Beginning with the first tab, you can choose from a variety of hole types, such as counterbore, countersink, and tapered tap, as well as from a variety of slots. For this example, I'll select the counterbore hole type. Next, you specify the dimension standard you wish to use, such as ANSI inch or ANSI metric. You then pick the type of fastener that will go in this hole, and the size. You can choose whether you want the hole to provide a close, normal, or a loose fit to the fastener. Next, you'll need to input a value for the depth of the hole. You can either type in a specific depth, or use an end condition such as through all. With the information you've provided, SolidWorks automatically knows the rest of the standard dimensions that define the hole, such as the counterbore depth and diameter. There are also options you can activate, such as additional clearance at the top of the hole, or a countersink. If you find yourself making modifications to these fields often, you may want to add your specifications to the list of favorites by clicking the Add or Update Favorites icon. This will make it easy for you to use your settings later, without having to type each one in every time you use it. After selecting the size and type of hole, I'll click on the second tab to position the hole. Here, I'm asked to select a face to position the hole on. You can select a 2D face to create holes on that face, Or if you want to create holes on multiple faces, you can click the 3D sketch button to place the location of the holes into a 3D sketch. 3D sketches are a bit too complex to go over in this course, so I'll stick to selecting flat faces for now. Once I select a face, notice that I'm placed in Edit Sketch mode, and that the point tool is activated automatically. This is useful because if you need more than just one hole, all you have to do is click to add more points to this sketch. Once you have the points you need, dimensions and relations can be applied to locate the holes. As soon as I click the green check, the holes are added. If you look at the feature tree, you will see the hole listed along with a description of the type and size. When the feature is expanded, you see there are two sketches used, one containing the individual points and the other containing the profile of the hole. If you need to make a change to the location or number of holes, all you have to do is click on the sketch containing the points and select Edit Sketch from the pop-up to make the changes there. However, if you need to change the type of hole, don't edit the other sketch. Instead, click on the hole feature itself and select Edit Feature. This will bring back the Hole Wizard property manager used to create the hole in the first place. You can make changes to the size and even the type of hole here. From the property manager, you can switch over to the Positions tab to change the hole locations, or add additional holes like I showed you a moment ago when editing the sketch. When I click OK, each hole is updated. The draft feature lets you add an angle to a face, or faces of a model. A draft is often required when creating plastic parts, because without angled faces, the parts would be unable to be removed from the mold. You can launch the draft feature from the Features tab of the Command Manager, or from the Insert drop-down menu under Features. The Draft Property Manager has two tabs, Manual and Draft Expert. The Manual tab gives you a little more control of how you want the draft feature to be applied, and you can create more complex draft features, such as a parting line draft or a step draft. However, for this example, we'll use the Draft Expert. With the Draft Expert, the Solidworks software will take care of all of the structuring of the features, so it's a little easier to use. The first item you need to specify here is the neutral plane. The neutral plane determines the direction of pull for creating molds. I'll select this face as the neutral plane. One nice thing about the Draft Expert is that it has the draft analysis tool built right in. You can check the Auto Paint box at the bottom of the Property Manager to show in the graphics area which faces have positive or negative draft. Next, I'll select the faces where I'd like the drafts to be added. And I'll specify a draft angle. Let's use 1 degree, just to give the faces enough of an angle so it can be ejected from a mold. When I click the Apply button, you can see the draft added to the faces.